Okay, now let's discuss the second practice exam. So first problem, find the distance and the midpoint between the pair of the point. So we are looking for the distance and the midpoint of this pair. The first point is -7, -2, and second point -1 and 3. All right. Okay, what's the problem? Okay, so the distance formula is square root of x1 minus x2 different square plus y1 minus y2 the different square. Okay, so x1 -7 minus x2 -1 the different square plus y1 -2 minus y2 3 square. -7 minus -1 is -7 plus 1. This is plus 1. -7 plus 1 is -6. -2 minus 3 is -5. So -6 squared 36, -5 squared 25. Add them together is 61. So it's a square root of 61. In the exam, leave this as your answer. Do not write decimal because you are not allowed to use a calculator. So square root of 61. Midpoint. Midpoint, x coordinate is x1 plus x2 over 2. Y coordinate, y1 plus y2 over 2. So it's -7 plus -1 over 2. -2 plus 3 over 2. So it becomes -7 plus -1 is -8 over 2 -4. -2 plus 3 is 1 over 2 is 1/2. So the midpoint is -4 1/2. -4 1/2. All right. So that's the first problem. Second problem, we have this quadratic equation 2x squared minus 4x plus 2y squared plus 5y minus 1 is equal to 0. And it claims that this equation represents a circle. We're looking for the center and the radius of the circle. So when you have such a problem, the first thing you see here, this is 2x squared, 2y squared. You're going to divide the equation by this coefficient 2. So we only want x squared plus y squared. We don't want the coefficient 2. So we divide the equation by coefficient 2. We will get x squared minus 4 over 2 is 2. 5 over 2 is a 5 over 2. And 1 over 2. Alright, you always get x squared, y squared directly, no coefficient. And second, I'm going to move this -1/2 to the right. Whatever constant, you're going to move to the right. And x squared with x term. Alright, so here, let me recall the formula. A plus b squared is a squared plus 2ab plus b squared, the complete square process formula. Alright, and you may have the counterpart. A minus b squared is a squared minus 2ab plus b squared. So in order to combine this x squared term with the x term by this formula, so you see here, you have x squared, which is a squared, minus 2x, so 2a. So you don't have b. Actually, here b is 1 times 1, right? So b is 1. So you need b squared. So add 1 squared. Remember, here we put additional add 1. That's for the first three. That's for the term x terms. For the y terms, y squared. We need 2ab. So 2 times 5 over 2 and over 2 again, 5 over 4. Then by this you can see this is y squared is a squared, 2, this is 2, y is this a, then b is 4 over 5. So you don't have this 4 over 5 squared, so you get 4 over 5 squared. And remember this 1/2, I move it to the right here. And this place you add a 1 square on the left hand side, so you're going to add a 1 square on the right hand side. Here you add 5 over 4 squared, so that's a formula. All right, so this is a complete square process. It's very important for the problem to find the center and the radius. Okay, so first the third term, x squared minus 2x and plus 1 becomes x minus 1 squared. The last three terms, it becomes y plus 5 over 4 squared. And the right side is 1/2 plus 1. 1/2 plus 1 is 3/2, and plus 25 over 16. 3/2 is, you multiply top and bottom by 8. Right? Multiply top and bottom by 8. So you got 24 over 16. Here's 25 over 16. Added them together is 49 over 16. So 49 over 16. Alright, once we reach this form, we know the center. Remember, the center is x minus h squared plus y minus k squared is equal to r squared. Then the center is hk. So you need x minus h, so h is 1. H is 1. And y minus k, here's y plus 5 over 4. Minus is minus negative 5 over 4. So center is 1 negative 5 over 4. The radius, the right hand side is r squared. R squared is 49 over 16, so it's a 7 over 4. Square root, this is a square root of 49 over 16. This one is a you can take the square root. If you cannot take square root, just leave it like this, square root of some number. All right, that's the second problem. Third problem. Write an equation of the line that passes through the point. So we need a line to pass through the point 1, negative 2, and 2, positive 1. Okay, so you don't have to sketch the graph, but let me sketch it and we see what it is. So 1, 2, 2, 1, 2, 1 is here, 2, 1. 1, negative 2, 1, negative 2 is here. This is a 1, negative 2. So you're going to write the equation of this line, So to write the equation, you need the slope. When you have 2 points, you can find the slope. The slope is, remember, slope is y2 minus y1 over x2 minus x1. It doesn't matter which point you name it as a 1 and the other one you name it as a 2, first and second. So for example here, it's a y2, assume y2 is negative 2, so it's a negative 2 minus 1 over 1 minus 2. Alright, so it's a negative 3 over negative 1 is a 3, so the slope is 3. When you get slope, you have 2 points. You can pick up either of them. Use a point slope form. Point slope form gives the equation. For example, let's pick up this 2, 1. So it's a y minus 1. Point slope form. It's y minus y coordinate is equal to the slope times x minus x coordinate. This is the equation of the line. Okay. Problem 4. Problem 4. Write equation of the line perpendicular to the line 5x minus 9y is equal to 45. So we want certain perpendicular condition, relative relation, and the new line, the second line, should pass through the point 1, negative 2. Two lines are perpendicular if the product of two slopes is negative 1. So first, we're looking for the slope of this line. So we move 5x to the right side and divide by negative 9. Okay, so this form gives us the slope. The slope is 5/9. Then the second line, assume the second line has slope m2. m2 times m1 is negative 1. So m2 is negative 1/m1. So you're going to flip m1 and put a negative sign. So negative 9/5. Negative 9/5. And this is a point slope form. It's y minus negative 2 is equal to negative 9/5 x minus 1. This is answer. Don't simplify it. Don't simplify it. Okay, so problem 5. What's the problem? Problem 5. We're looking for the xy intercept of the function of the equation. The equation is y squared plus 4y is equal to x squared plus 4x and plus 4. Okay, let's check. X-intercept, we let y be 0. To find x-intercept, you're going to let y be 0. Y is 0, so the left side is 0. Right side is x squared plus 4x and plus 4. This is quadratic equation. Either you can factor it or you can use root formula. This is exactly the complete square. So it's x plus 2 squared. X is equal to negative 2. So there is a repeated x-intercept. But anyway, the x-intercept is negative 2. X-intercept is negative 2. It's just the number, x value. Y-intercept, you let x be 0. When x is 0, so it's y squared plus 4y is equal to 4. So y squared plus 4y minus 4 is 0. You move 4 to the left side, is minus 4 equal to 0. This one, we cannot factor it. We're going to use root formula. Negative b plus or minus square root of a b squared minus 4ac. It's negative 4 plus minus square root of a 32 over 2. 32 is a 16, so it's a 16 times 2. So plus minus 4 times square root of 2 over 2 is negative 2 plus or minus 2 square root of 2. So there are two y-intercept, negative 2 plus 2 root 2 and negative 2 minus 2 root 2. It's a y-intercept. This is equation, not function, so it may have several y-intercept. Y-intercept is not unique in this case. Okay. 6. Find the equation of the parabola with the focus 0, 3, and the directrix y is equal to negative 3. It's like this. Such a parabola is x squared is equal to 4ay. X squared is equal to 4ay. If we have a here, negative a here. This horizontal line is the directrix, y equal to negative a. The focus is 0a. So here a is a 3, so the equation becomes x squared is equal to 3 times 4, 12y. This is the answer. Be careful. Sometimes they may provide the vertex. Vertex is 0, is just 0, 0. If vertex is 0, 0, focus is 0, 3. This is the end. This is the end of the answer. I'm going to give another remark. So if vertex is 0, 0, and the focus is 0, 3, this will also tell us, this combination will also tell us a is equal to 3, and the equation is x squared is equal to 12y. Alright, so these two conditions, if you see these two conditions in the exam, then it will tell you a is 3 and the equations like this. If they tell you the vertex is 0, 0, and the directrix is y equal to negative 3, this also tells you a is 3, because this is a, this is also a. So those two conditions just give us the a, and the equation is again x squared is equal to 12y. So 3 conditions: focus, directrix, and the vertex. Once you get 2, you can determine this a and write down the equation. Okay, so the answer, you don't have this part in the problem. The answer is x squared is equal to 12y. Okay, problem 7. Problem 7, determine the domain of the function. So here is a function fx equal to 4th root of negative x squared plus x. We already discussed this in the section about the library of the functions. So whenever you have the 4th root, the domain, like whatever inside, it should be greater than or equal to 0. It has the same domain as the square root of x. So the requirement for this function is that the negative x squared plus x should be greater than or equal to 0. And you multiply this inequality by negative 1, you will get x squared minus x is less than or equal to 0. When you multiply the inequality by a negative number, you are going to change the direction. And this one, remember, we discussed when the leading coefficient is positive, the parabola will have such graph, the opening is upward. You will have 2 solutions. So you find the solution x squared minus x equal to 0. Then x times x minus 1 is equal to 0. X is 0 or x is 1. So you have 2 solutions, 0 and 1. And this time we are looking for, you see here, we're talking about this inequality, not the original one. This one, currently we're talking about this inequality. We want the solution set so that it makes this difference less than or equal to 0. So here, less than or equal to 0 is below the x-axis. So x should be between 0 and 1. So the domain is 0, 1. It contains equality, so we use bracket to include 0 and 1. Alright. Problem 8. Let function f be 2x over x minus 2. The part A question is a point 1/2 negative 2/3 on the graph of f. So if we want to check if a given point is on the graph or not, we just try to evaluate the function at the x coordinate. So f1 half. f1 half is 2 times 1 half, and 1 half minus 2 is 1 over negative 3 halves is negative 2 over 3, right? Okay, so this value, you just check it. It is equal to the y coordinate of the given point. So the answer will be yes, it is on the graph. If your result is not equal to the given the y coordinate of the given point, then it will be no, it is not on the graph. Alright, so you only evaluate the function at x coordinate and compare your value with the y coordinate. Equal is yes, not equal is no. Part B, if fx is equal to 1, what is x? fx is 1, so it means 2x over x minus 2 is equal to 1. So you're going to solve for x. You multiply two sides by x minus 2. You multiply this by x minus 2, you get 2x is equal to x minus 2. So cancel x, x is negative 2. X is equal to negative 2. So what is x? X is negative 2. Problem 9. Find the average rate of change for the function. Function is 2x squared minus 4. The given interval is 1, 4. Average rate of change. Average rate of the change is fb minus fa over b minus a. fb minus fa over b minus a. If you remember, this is actually also the slope calculation. Slope of the second line. But anyway, fb, b is a 4, a is a 1. So this is a, this is b. f4 is a 2 times 4 squared minus 4. This is f4. And minus f1 is a 2 times 1 squared minus 4. And 4 minus 1. 4 squared 16 times 2 32 minus 4. 2 times 1 is 1. 2 times 1 is 2. 2 minus 4 is negative 2 over 3. 32 minus 4 is 28. 28 minus negative 2 is plus 2. So it's 30 over 3 is equal to 10. So the average rate of change is 10. Problem 10. Prove that this given function of value of x plus 3x to the fourth power is an even function. Alright, to show it is an even function or to show it is an odd function, you always start from f negative x. It's always the starting point. So f negative x, by definition, is absolute value of negative x plus 3 times negative x to fourth power. Right? This is the evaluation. And then you're going to use whatever formula you know to simplify this evaluation. Absolute value of negative x is absolute value of x. It doesn't matter you put a negative sign or you do not inside the absolute value. And the negative x to fourth power, you have even power, so it's just x to fourth power. So this one, you check it, it's exactly fx, the formula of fx, exactly the same thing. So you start from f negative x, and eventually you reach fx. So f is an even function. F is an even function. Okay, problem 11. Problem 11. Show that this function g of x, which is x over x plus x squared plus 1, is neither even nor odd. whatever. You have even odd problem, you always compute g negative x. G negative x, by definition, is negative x. Whenever you have x, you put a negative x. You have x, then you write negative x. You have x here, you put a negative x. But you have to put parentheses also, and the square, and plus 1. So it's negative x, and negative x, and negative x squared is x squared plus 1. Okay, now you see, check this. This formula is not gx. Gx has such form, and this one has this form. There's no way to simplify. So it's not equal to gx. It's not equal to gx. G is not even. Right? And then let's check negative gx. Negative gx is negative x over x plus x squared plus 1. You can put negative sign here, or you can put together with x. Okay, this expression is negative gx. You compare this expression with this one. This is g of negative x. These two things are almost the same, but they are not the same. Here, this is negative x, this is x. They're different. So you get it's not equal to g negative x. So negative gx is not equal to g negative x. So g is not odd. To have even or odd, you must have exactly the same thing. It's like here. Like here. In this part, you see this expression. This is a simplified version of an evaluation. This expression is exactly no solution, just compare. It's exactly fx, so that you can put equal. But here, this one, they're different. And this one is still different. So the function g is not even, not odd. So you are done. Alright, so that is the complete discussion of the practice exam for the second one. And if you have a question, ask me after class. Okay, thank you.